checking 1, 2, 3. Looks like we are live, but let me check the stream real quick. We start in a few minutes. Looks good. Looks like we are live. So if you have any question, please post that on the chat. I will check that regularly and should be able to answer that. And also, you will see that there will be the list of the topics of the test that we'll go over will be on the top. And we start in a few minutes. I just need to check a few things before we start. Right, good. I just need to change the focus a little bit. That's good. Okay, we'll start. I will start with the list of the question on the top. The first one is matrix operation. So we will be given a matrix and we just do some operation. Pretty standard, like this type of problem here. If you have any questions, please post on the chat and I will check that regularly. But first, let's look at question number 2. So pretty standard. For something like this, we can do by hand or we use the calculator. It doesn't really matter. I'll do it by hand first and then we use calculator. Right. So to do this by hand, first we have 2 times the matrix A transpose and then minus B. So we have 2 times the matrix A transpose and then minus the matrix B. First we'll do the transpose. The transpose meaning the row, we turn the row into the column. We still have a 2 in front of it. The first row 1, negative 2 and 4 becomes the first column. And then the second row is the second column. And then minus the matrix B. Next we have 2 times the matrix A transpose, so we multiply 2 into all of this entry and we will have 2, 10, negative 4, 16, 8, and 0, and then subtract the matrix B. So we will have 2 minus 9 will be 7, negative 7. 10 minus 1 is 9. Negative 4 minus 4 is negative 8. And 16 minus negative 2 will be plus 2, so 16 plus 2 is 18. 8 minus 0 is 8, and 0 minus 5 is minus 5. So that's I will do that by hand, and we use the calculator to check our calculation. I guess just put it there. Right, turn it on. I'm just going to put this into the calculator. So we have 2 times. On the calculator, we hit alpha, zoom, the bottom menu pop up, and that is 2 rows and 3 columns. Okay, and then we enter the number 1, negative 2, 4, 5, 8, 0, and then transpose. Transpose is under the matrix, second matrix. Go to math, option number 2. So that is transpose minus alpha zoom. This is a 3 by 2 matrix, and the value is 9, 1, 4, negative 2, 0, and 5. Right, just go back. I just want to go back and check the values and all. Right, so 1, 5, 1, negative 2, 4, 5, 8. Right, hit enter, and we have negative 7, 9, negative 8, 18, 8, and negative 5. Yes, so that's what we have. So that's pretty standard on the matrix operation, and we can either use do it by hand or use a calculator. This should be pretty simple. Right, we go to the second part of the list is about inverse. Oh, never mind. I think we should do a matrix product as well. So go to 3. Next, multiply matrices. We should do that. We multiply A times B. Now first we check the dimension. A is a 2 by 2. Matrix B is 2 rows, 3 columns, 2 by 3. Because of that, the product of AB, the middle number have to match, as you have 2 and 2, which is without the same, which is good, and the outside number will give us the dimension of the product. So we have 2 by 3 on the outside, so the product is going to be 2 by 3. So now it's A times B, negative 1 and 3, 1 and 6, 0, negative 2, 7, 1, negative 3, and 2. Alright, we know when we multiply it is going to be a 2 by 3 matrix. So we're going to have a 2 by 3 matrix. Right, and each one of this product matrix will come from the row and the column. The row from the first matrix and the column from the second matrix. I'll just do some of them. Let's say if we want this entry right here, that is on the first row and the second column. The row from the first matrix and the column come from the second matrix. So each one has 2, -1 times -2 plus 3 times -3. So we'll have -1 times -2 plus 3 times -3. That gives us the entry right here. -3, -9 will be -12. Sorry, that is -1 and -2, so that should be 3, so that's -6. Sorry, that should be -6. Let's say if we want this entry right here, that is on the second row, the third column, second row, and the third column. 1 times 7 plus 6 times 2. So that is 7 and 12. That will be 19. And when we use the calculator, we can confirm our calculation. Of course, we can do like this and we get the rest of the matrix. So alpha zoom, we have a 2 by 2. -1. The negative is here and not the subtract sign. -1, 3, 1 and 6. Multiply by the matrix, 2 row, 3 column. -0, -2, 7, 1, -3, and 2. Alright. Just I don't know how I do the simple calculation. At least we have the calculator to confirm that. Sorry, that should be -7. That is obvious. That's 19. 3, -1, 6, and -20. Right. Again, that is -7. Sorry about that. I'm surprised I didn't see anybody say anything on the chat. Right. Anyway. So that is the matrix operation, and we did those 2 questions. That should be simple. Alright. Next we'll do the inverse matrix. We will on the inverse matrix, I can ask you to find the inverse of 2 by 2 like this. We do that inverse 3 by 3 by hand as well. But so there's a few things we can find. First, inverse of a 2 by 2. Inverse of a 2 by 2. 1 minus AD minus BC, which we now know is the determinant. Right. These 2 elements here will interchange. So we will have D and A. And these 2 elements, we just change the sign. To negative. Right. And pretty standard here. So we have A inverse 1 over 0 times -4 minus 6 times -4 times 0 -4 will interchange -4 and 0, and 6 and -4 negate, so change the sign, negative to positive, positive to negative. And so we have 1 over 0 times anything is 0. It will be just 1 over 24. Negative 4, negative 6, 4 and 0. And we multiply 1 over 24 into every entry of the matrix. Negative 4 divided by 24 is negative 1 over 6. Negative 6 over 24 is negative 1 over 4. And 1 over 6 and 0. So that is inverse of a 2 by 2 matrix. If we use the calculator, we just type the matrix. And the inverse is just this button. We can convert to fraction math and then change to fraction. Just hit enter. 1, 2, and that's what we have. Right. Keep there for a moment. For next problem, I need to load the, see if I can load the operation on here. No, I cannot. So just have to do it by hand for the next one. Or just do that the old school way. Right. Our next problem, we will use the row operation to find the inverse of a 3 by 3 matrix. By the way, you will see one question like this on the test. So what we do is we just do the row operation on the matrix, augmented matrix A and identity. So the same row operation. So pretty much this is the idea. We have the augmented matrix of I, A, and identity matrix. When we do the row operation, if we reduce A to I, then those same operation will reduce I to A inverse. Right, so that's what we're going to do. So first we're going to put the matrix 1, 1, 1, 2, 1, 1, 2, 2, and 3. On the right hand side, we're going to have the identity matrix 1 on the diagonal and 0 everywhere else. And we're going to do the row operation on this augmented matrix. Right. So first thing, we have the pivot entry here, which is good. We will turn this to 0 and this to 0. When we turn something to 0 using that pivot, that means we're going to use row 1. Now, to eliminate the 2, we use opposite to that, and the 2 is on row 2, so we add and replace to row 2. And then add negative 2 to row 3 and replace to row 3. So we will do those two operations. Right. So first I put the 3 by 6 augmented matrix in the calculator. 3 by 6. 1, 1, 1, 1, 0, 0. 2, 1, 1, 0, 1, 0. 2, 2, 3, 0, 0, 1. Right. Let's see. 1, 1, 1, 0, 0, 2, 1, 1, 0, 1, 0, 2, 2, 3. Right. So that's good. We have the matrix A. Now we're going to do the row operation. Hit program, row ops, apply that to matrix A. Right, hit enter to continue. Alright, we're going to do the multiple one row and add and replace, so that will be option number 4. Multiply row 1 by -2, add to row 2. Alright, so that's 0, which is good. Next, hit enter to continue, option number 4 again. Multiply row, just hit number 4, don't need to hit enter. So multiply row 1 by -2, add and replace to row 3. Right, I'm going to write this down. This is going to be 3 by 6, 1, 1, 1, the first row, 0, -1, -1, 0, 0, 1. And we have 1, 0, 0, -2, 1, 0, -2, 0, 1. Right, so now we check 1, 0, 0. That's good. Now we go to the second column. The second column, the pivot here needs to be 1, so we need this to be 1. So we just multiply second row by -2, -1. And we'll do that. Enter to continue. Multiply a row, we use option number 3 here. Multiply row 2, let's multiply by -1. Right, and we have that. 1, 1, 1, 1, 0, 0, 0, 1, 1, 2, -1, 0, 0, 0, 1, -2, 0, 1. Alright. Next, that's good, that's good, that's good. The pivot here is good. We need this to 0. So we will, the pivot is at row 2, and we're trying to eliminate row 1, and we use opposite to that. Four, multiply row 2 by -1, add it to row 1. Multiply row 2 by -1, add it to row 1, and we have 1, 0, 0, -1, 1, 0, 0, 1, 1, 2, -1, 0, 0, 0, 1, -2, 0, and 1. Right. And let's check. We have 1, 0, 0, which is good. We have 1, 0, and 0, good. This one is good. That one is good. The only operation we need to do is just turn this into a 0. To do that, the pivot is at row 3 now. So we multiply row 3. The pivot. We're trying to eliminate row 2. So we're going to add and replace to row 2. And we need to multiply by -1. So we're going to do that. And that's the last operation we need. Option number 4. So I hit number 4. Multiply row 3 by -1. Add to row 2. And look like that's what we have. So we have 1, 0, 0, -1, 1 0 0 1 0 4 negative 1 negative 1 0 0 1 negative 2 0 and 1. Right. And so we have the identity on the left hand side, then the right hand side must be the inverse of A. If we do not have the identity on the left, then the inverse does not exist. Right. So that is the inverse. Next, we use inverse to solve the system of equation. That will be on number 6 here. So let me update the list. We have 4 to 6. Right. Check this out later. Next, we use inverse to solve the system equation. So it looks like they have like 15-second delayed. Right. Next, we use the inverse to solve the system of equation. So from this one, we will write the matrix equation. Let me write what we need here. So matrix equation. There will be a different form, but the form we're interested in is AX equal to B. And what we do is we multiply the inverse on both sides. Note that we multiply in front of the matrix. Either we multiply everything in front or everything on the right. Right. So A inverse times A, because that is the identity matrix. So we have the identity matrix times X equal to A inverse times the vector B inverse times, identity times anything itself. So we just have vector X equal to A inverse B. So the matrix equation is in this form, and the solution is in this form. So we're just going to write this system of equation in terms of matrix equation 1 2 3 1 1 1 2 2 1, and the matrix X is the matrix of all the variable. We have X, Y, and Z, and that's multiplied by negative 4, 1, and negative 5. So this is going to be the coefficient matrix A, the variable vector X, and the constant vector B. So we have the solution in this form. So we just say X equal to A inverse times B. In this problem, we are given the inverse. So inverse of this matrix is equal to this matrix here. So we just take the inverse, which is this 3 by 3 matrix. Times the matrix B, which is negative 4, 1, and negative 5. And when we multiply, we have the result which corresponding to X, Y, and Z. So this is simple enough, so I'll let you do that. Right. Next, we do operation on block matrices. That will be the next two problems. Right, so we have A and B, both of them 3 by 3. So let I put that, need to put this somewhere. A is 3 by 3, B is 3 by 3. The product is also 3 by 3 because the middle number match. Now, in terms of blocks, our matrix A will have 2 blocks, mean 1 by 2. And matrix B in terms of blocks is going to be 2 rows, 2 columns. So when we multiply the product, the middle numbers are the same. So in terms of block, the result going to be 1 by 2 in terms of blocks. Now we multiply. A times B in terms of blocks, 4, 0, 2, -1, 5, and 3. And we use the bar just to divide the blocks. It is not a romantic matrix. So that is A, and then B, -2, 0, 8. Sorry, B is 3 by 4. So we're going to have 3 by 4. Again, if you see anything strange, please post that on the chat. Usually I'll be more careful, but since it's the live stream, so I rely more on extra set of eyes. Right, anyway, so now we multiply. Notice that it is in terms of blocks 1 by 2 times 2 by 2. So the first one is the first row in blocks times the first column. By the way, the result is going to be 1 by 2. So first row times column. So first we're going to take this, that is in terms of a row, times this column. So we have 4, 0, 2, -1, 5, and 3. That multiplied by -2, 0, 8, 1, 6, and 2. Plus 1, -3, 7 times 1, -3, 7 times 4, -1, and 0. So that gives us the first block. Because the first row times first column gives us just 1 block. The second block is we're going to use again the same first row, but this time we use this column instead. So before 0, 2, -1, 5, and 3 multiplied by 5 and 2 plus 1, -3, 7 times 3. So that's what we have. Right. And if we just do the math, that look complicated. I'm just use a calculator with help on calculator on this one. calculator. Alright. Right. That is 3 rows, 2 columns. 4, 0, 2, -1, 5, and 3. Alpha zoom. This is the next one, 2 by 3. Oh, now I see. Because there's like the 20-second lags. So usually if there's a mistake, you will see that in 20 seconds. So kind of difficult to catch any error anyway. So 402 -153. Right, and that plus the matrix 3 row 1 column. -1, -3, and 7 times a matrix 1 row 3 column. -4, -1, and 0. We do that, and we have -4, -1, 32, -17, -3, 14, 21, 11, and 46. And then the second block, we do the same thing. Just put this second block into it. If we do that, look like 23, 10, -2, 8, -9 is -1, 25, and 631 plus 21, 31, 21 as 52. Right. So we're going to have, as mentioned before, 1 by 2 blocks. 1 by 2. Right. So just multiply in the blocks form. Right. The next one's easy. We just read that just like letters. Variable here. So W, X, Y, Z. So just row times column. Don't need a calculator on this one. So row, first row times first column, 0 times W plus I times Y, 0 times X plus I times Z, that's the second column, I times W, second row, and first column, and then IX plus FZ. 0 times anything is going to be 0. Identity times anything it itself. So we just have Y, Z, W plus FY. Sorry, this is a bad way to write this. And X plus FZ. So that is a 2 by 2 block. Yes, the identity matrix, I will be the identity matrix. And we assume that each block, the dimension are divided so that it will multiply. It can be multiplied. So all of them are square, I assume. Yeah, so identity here is I. Right. So that is the operation on block matrices. Next, we have LU factorization. First, on number 9, we use the given the lower triangular matrix and the lower triangular matrix. This is lower triangular matrix, and this is the upper triangular matrix. We're going to use that to solve for x. So again, the same matrix equation: ax equal to b. A is factorized into LU times x equal to b. Now if we let ux equal to y, the vector y, then we have ly equal to b. Right. From this equation, we can solve for b. Solve for y, and then when we get back to ux equal to y, we can solve for x. And that how we use the LU factorization to solve for x. Yeah, you need to demonstrate that you know how to do this on the test. Of course, the system of equation like this, by now we know 5 different ways to do it, but I want you to use the lower and upper triangular matrix. So first, ly equal to b. So first part, ly equal to b. So we're going to write out the L 1 0 0 negative 1 negative 2 1 0 3 4 and 1. That multiplied by y, so let's say y1 y2 and y3, and that's supposed to be equal to b, which is 6 negative 3 and 2. What we see here is the first equation. Obviously we just have 1 times y1, 0 times y2, 0 times y3, so pretty much we just have y1 equal to 6. That's the first part. Next, we have negative 2y1 plus y2 equal to negative 3. We know y1 is 6, so that would be negative 2 times 6 plus y2 equal to negative 3. So that's negative 12. Move to the other side, that will be 12. 12 minus 3 will be 9. So y2 is equal to 9. And then the last row, we can have 3y1, 4y2, and y3 is equal to 2. If we solve for y3, it is going to be 2 minus 3y1 minus 4y2, and 2 minus 3, y1 is 6, y2 is 9. So that's what we have. So that will be 2 minus 18 minus 36. So that's minus 52. That is y3. Right. Next, so this is the first part, Ly equal to b. We solve for y, and after that ux equal to y, and we're going to solve for x. So ux equal to y. U is this. X, let's say x1, x2, and x3 equal to y, y1, y2, y3. Right. If on this problem we use the forward substitution, we go from the top to the bottom. On this step, we're going to go from the bottom to the top. That is called the backward substitution. So from this last one, we have for x3 equal to negative 52. So x3 is negative 13. The second equation, we have 2x2 minus x3 equal to 9. So we will have x2 already. X3 is negative 13, so let's just put negative 13 there. 2x2 negative 13 equal to 9. Move the 13 on the other side. We'll have negative 13, that's negative 4. So 2x2 equal to negative 4. So x2 is negative 2. And finally, the top equation, 3x1 minus x2 plus 2x3 equal to 6. X1, so we just say 3x1 minus x2, which is negative 2, and x3 is negative 13 equal to 6. So let's see, we have 2 minus 26 to be 20 minus 24. On the other side will be positive 24, and 6, 30 divided by 3. So x1 is equal to 10. So with that, we have x1, x2, x3 is 10, negative 2, and negative 13. That's what we have. Right. Next, we will find the LU factorization for a given matrix. This is it's not as complicated as finding the inverse. Right, so we just have the matrix. What we're going to do is just do the to find the echelon form. Just echelon form. Do not do any row swapping. Just multiply a row by a constant. That's good. Just row replacement. That is right. So remember, just row replacement. We're going to do 10, by the way. Right. So on the first one, we're going to keep the 2 here as the pivot, and we turn the other two to 0. So we base everything on the first row, and if we eliminate row 2, we're going to add and replace to row 2 the 4. To eliminate 4 from 2, we need to multiply by -2, and then we eliminate row 3, store and replace to row 3 by -2. Right? We use this calculator. Right, I'll just store a 3 by 3 matrix. Usually we just need about 3 operations, and that will be enough for this kind of problem. So right, 3 by 3, 2, 4, 5, 4, 11, 5, 4, -1, 24. Right, let's see that again. Right, program row off matrix 8. Alright, option number 4, I just hit 4, multiply row 1 by -2, add to row 2, enter to continue, hit enter. Option number 4, I just hit 4, multiply row 1 by -2, add to row 3, and we have this. So that's the first step. So the first column is done. Next, the pivot is going to be the first non-zero entry, so it's going to be here, and we turn the -9 to 0. So we spin on row 2 to eliminate -9. -9 on row 3, so we'll add and replace to row 3. And to eliminate -9, we use -3. So option number 4, multiply row 2 by -3, add to row 3. Right. Wait. Should multiply by 3. Well, that's okay. Multiply row 2. This I need to multiply by 6. Add to row 3. Right. Now we're good. 2, 4, 5, 0, 3. Sorry, this should be +3, and that's why the problem is where the problem is. It should be 3. So that is our upper triangular matrix. So this is going to be U. Right. For the lower triangular matrix, we know that it's going to be in this form. It is lower, so above the diagonal is going to be 1, and above it must be 0. So that's going to be our lower triangular. It's going to be in that form. By the way, lower triangular is always a square matrix, so we always have 1 on the diagonal. The upper triangular might not have to be a square matrix. It could be any dimension. Right. To determine the rest, it should be simple. We look at the original problem. We have 2, 4, 4, and to turn that into this column, we divide everything by 2. Give us 1, 2, and 2. and that is where we have the pivot there. Now we have the one here, that's where we have the pivot in this row, and we're going to turn this one and to turn the 3 to a 1 we divide by 3, and that gives us 1 and -3, and that is our lower triangular matrix. Right, so that's how we decompose it. Right. So now I think we've done the more complicated parts, the tiers calculation. The rest is require a lot more know-how than just the calculation to go through it. Now we need to know more about the determinant. We have a lot of questions about determinant on this test. So, for example, we need to know how to evaluate the determinant based on the cofactor expansion. Right. So first, we're going to use any row or any column. Usually, we pick the one with the most 0. So I'm going to pick this one. By the way, let that be the matrix A. So we say determinant of matrix A. Either we're going to write like that, or we can also say determinant of matrix A using the 2 bars for the notation. Right. So we're going to have -5 and then a bunch of 0. 4 we have -5, and then we look at the sign chart. The sign will be alternating. The first one is plus, minus, plus, and minus. So same, negative, same, negative. Right. And then for the 5 we're going to cover that up. And that. So what left is a 3 by 3 determinant, -1, 2, and -2, 3, 0, 0, 3, 1, 4. Right. Next, we're going to cover the row and the column that have this 0. So we're going to have 5, -5, and 3, 3, 0, 0, 3, 1, 4. We can keep doing that. Yeah, I skipped 12 because that's simple enough. We're not going to go over every problem. Yeah, because once you know how to do this, then you can go back and do that. Pretty simple. Besides, you probably have just one question like this. Right. By the way, because this is 0, so all of this goes to 0. Doesn't matter what this is, still 0. That's still 0. So that is pretty much what we have. It's just this. Right. Next, we're going to have -5. For the 3 by 3 determinant, let me copy that. Right. Thank you. -1, 2, -2, 3, 0, 0. Yes. Yeah. When I cover it, I didn't see. So now, for this 3 by 3, I'm sorry. We're going to pick the row or the column that has the most 0. So it could be wise if we're going to pick this second row here. So we have -5, and then 3, 0, and 0. Right. Again, we cover the row and the column. But first, the sign. The first one is positive. This should be negative. the same and opposite. Right, now 2 by 2. Cover the 3 here, we have 2, negative 2, 1 and 4. Cover the 0, we have something, and cover the 0 here, we have something. It doesn't matter because it goes to 0. So we just have negative 5 times negative 3, that is 15, 2, negative 2, 1 and 4. So 2 by 2 determinant should be easy. 2 times 4 minus negative 2 times 1. So that will be 6 plus 2 is 8 times 5 times 15, so will be 120. Wait. It's going to be 8 plus 2 will be 10 times 5, 15 will be 150. Sorry. 8 and 2, 10, so 150. Yes. Right. Of course, the determinant is very easy to do. On number 12, we just something like that. We just use a calculator, and if we want the determinant, it is going to be second matrix. Determinant will be around the first one. Second matrix, go to math, the second tab, determinant, and then we just put the matrix, whatever the dimension is, and we just find the determinant. So that's easy. You don't see a lot of this on the test. Just one question using the cofactor expansion. Most of the question will be like this. Right. So for something like this, obviously we won't be able to use like what we did before, or use a calculator, simply because the asterisk here will take any values. So what we see is that if we have the row of this and this, those two rows are the same, meaning that those 3 rows are not linearly independent, so the determinant is going to be 0, so we don't have to do anything. And on the test we said if we have any rows that are the same, or any row that are, any column that are the same, we just say determinant of whatever that matrix is, we just state this equal to 0. So that only we need, really. Just say that the same equal to 0. Right. That's one way to do it. The other way doesn't take any more times. Just do one row operation. Just row 1, trying to eliminate this to 0. So row 1, negative row 1 plus row 3, replace to row 3, and do that. We're going to have 1, 2, 5, 2 star and star, 0, 0, 0. And now if we expand along this row, of course we're going to have 0, 0, 0 times a bunch of submatrix, and ultimately it's going to be 0. So determinant is equal to 0 for that one. Yeah. So if we have a row of 0, that is determinant is 0. If we have 2 rows are the same, or 2 columns are the same, determinant will be 0. Right. And also when we do this operation, that is perfectly fine. The determinant will not change. Right. Next, on this one, of course we have the star again, so we'll not be able to use the calculator on this one. What we do is we're trying to turn this to a 0. So we're going to have, based on row 3, and eliminate row 4. So we have negative 1/2 times 2, that will be the same. This is simple enough. This is simple enough. We just do it by hand. We're going to have the determinant 1, -3, star 5, 0, -2, 4, asterisk or star, doesn't matter, 0, 0, 2, and 1, and then 0, 0, 1. -1/2 times 2 is -1 plus 1 will be 0. -1/2 times 1 is -1/2 plus 7. 7 minus a half is -6.5. over 2. Now what we have here is the upper triangular matrix. So if it is upper triangular, lower triangular, or diagonal matrix, we just multiply the diagonal entries. So multiply all of that. So we say determinant is, when we do this row operation, determinant doesn't change. And so we just have 1 times -2 times 2 times -13 over 2. I think the answer on the back of the test is incorrect in this one. It's a -2 and 2 cancel here, so we're going to have 26. Right. So the fact that now we just write a few things. If we have the whole row 0, that is 0. If we have 2 rows are the same, 2 columns are the same, determinant is 0. Now this is another rule. Triangular, either upper triangular or lower triangular or diagonal matrices, determinant of them is just the product of the diagonal entries. So triangular matrix, diagonal matrix, that triangular meaning either upper triangular in this case or lower triangular, the determinant is going to be the product of the diagonal entry. Oh yes, sorry, this should be positive. That could be -26. Thanks. Right. So that. So if we go back, the determinant of this matrix is going to be 1, because 1 times 1 times 1. Yes. On this one, when we do the row operation, this row operation itself, determinant is going to be the same. And so the product of the diagonal, so that could be, this case, -26. Thanks for the correction. Right. So there will be more on the determinants. So yeah, 0, 0, and triangular and that. Right. Next, find the determinant 2 times the matrix A transpose. So to do this, let's first find the determinant of matrix A. Determinant of matrix A, 1 times 4 minus 3 times -2. So that would be 4, and 6 will be 10. Right. So determinant of matrix A is 10. Now we're going to use that and find determinant of 2 times A transpose. Next, determinant of that. Now if we have the 2 multiplied by the matrix, so we just look at this example I think we did in class. Let's say we have the identity matrix 3 by 3. If we multiply the whole row by 2, then we're going to have 2 0 0 0 1 0 0 0 1. Determinant is going to be 2 times that's going to be 2. So if we multiply any row or any column by a number, then the determinant just multiply by that same number. Now if we multiply by 2 into this matrix, notice that when we multiply by 2, we multiply by the first row by 2, the second row by 2, which means we do that twice. So we have to have 2 to the second power of determinant of A transpose. Now remember, when we do the determinant, we can base on any row or any column. So determinant of A transpose is the same as determinant of A. So when we do that, we just have 40. Right. Here's the fact. If A is n by n, then determinant of a constant times A is going to be k to the n power times the determinant of A. So this is another fact that you need to know for the test. And this kind of subtle, but determinant of a transpose is just determinant of the matrix, nothing changes. Right. So that's what we have. We do need to know the dimension of the matrix. This one has 2 rows or 2 columns, so we have to raise to that power. If we have -2, then we have -2 raised to that power. Alright. Next we'll go to 17. This definitely you will see it because I want to test the concept of determinant, not just evaluate it. Something like this is too easy. The calculator can do it. This we need to have some human input. Right. So we try to find determinant of A inverse times B. So there's a few things we need to know. Determinant of a product, I use M and N because I don't want to get into A and B thing. It's going to be the product of determinant. Of course, if they are square and they can multiply. So determinant of a product is the product of determinant. Right. We are given determinant of B is -20, so that is given, which is good. Now we just need to find the determinant of A inverse. So that will be another properties. Determinant of the inverse is going to be, almost say it, inverse of the determinant. That's sorry, 1 over is inverse already. I should say reciprocal. So there's nothing here. Never mind. So determinant of the inverse is the reciprocal of the determinant. So we just have 1 over determinant of A, and then determinant of B. I use the bar for the notation of determinant. You can use DET for that. That works just as good. Right. So we have 1 over 5 times determinant of B is -20. So that will be just -4. Right, so that's all the determinant, and we have from 13 to 617. Right. Next, Cramer's rule. So first, for Cramer's rule, we're going to have all of the determinants. On the test, I probably will ask you a 2 by 2 determinant like this, or if it is the system of 3 equations, I only ask you to find one variable. Right. So first we're going to have the determinant D will be all the coefficient on this side. 2, 3, 3, negative 2. Determinant is negative 4. Negative 4 minus 9, so negative 13. And then we have D1. For D1, we will replace this last column into the coefficient of x1. Do that, we're going to have 18 and 3, 28 and 3, 3 and negative 2. So 28 and negative 2, negative 56, minus 3 times 3. 56, 9, negative 56, and negative 9, negative 65. Right. D2, we will replace that into the coefficient of x2. So in that case, coefficient of x1 will stay the same, and we have 28 and 3. So be 2 and 3, that's 6, minus, sorry, 28 and 3, 28 and 3, 84, 84, 6 will be 78, negative 78. Right, so we have D1 and D2. After that, x1 is D1 over D, negative 65 over negative 13 is 5. X2 is D2 over D, negative 78 over negative 13 is 6, so we have 5 and 6. We will not do this one, we just need to set this up. This we only need to find x. So first the D is the coefficient matrix. 5, 4, negative 1, 1, negative 3, and 4, 2, 1, and 1. And then we're going to find the x. We replace this into the x coefficient. When you find the determinant, x is going to be equal to dx over d, and whatever that is. So that is the Cramer's rule. 3 by 3, if it is 3 by 3, I mean 3 equations, 3 variables on the test, I will just ask you to find one variable. I don't ask you to find the whole thing. That would be too much. So that is Cramer's rule, 1819. I think I should do at least some of the question 20, so we haven't done yet. 20 is also Cramer's rule. So first we're going to find determinant D of the owner coefficient. In this case, give us S, negative 7, S, 3, and negative 21, S. Right. 2 by 2 determinant give us negative 21 S squared plus 21 S. So that is D. Right. Next, we do D1. We will replace 3 and 5 into this column, and we have negative 7S, negative 21S, determinant negative 63S, going to be plus 35S. 63 minus 35 is going to be 28. And the same thing, you can find D2. I leave that part to you. So then we have x1 is equal to D1 over D 20S over negative 21S squared plus 21S. Look like we can factor 1S at the bottom, negative S. Then we have, we should put negative 21, factor negative 21 out. 20S on the top, negative 21S at the bottom, and then S minus 1. Right. And then just cancel. S and S cancel. 20 and 21 look like it's going to be negative 4 over 3, 4 and then 3, S minus 1. And obviously S cannot equal to 0 and S cannot equal to 1. Otherwise, when we divide like this, it's going to be 0. So which is a unique solution. Unique solution is where S is not equal to 0 or 1. Otherwise, we divide by 0 and that will be no solution. Again, I forgot the negative. That's positive. Thanks. I just find D2. Why not? So it's going to be 5S minus 9. So x2 is going to be D2 over D. D2 is 5S minus 9 over D will be that. Yeah. This is not going to simplify anything, so I'm going to just leave it like that. So that is the determinant. and the Cramer's rule, I mean. Right. Next we use the transformation to find the area and determinant as well. Right. So first I'm going to try to draw this parallelogram. So we have 0, 0. Let's use blue. And 2 and 6, 2 and 6. And then 8 and 10, 8 and 10. And then 6 and 4. Looks like we have a parallelogram here. We're trying to find the area of this, and this is the parallelogram P. Right. Of course, we can try to find the area using the formula. That's simple enough. But let's use transformation here. What we do is we try to draw the unit square. The unit square will be the length 1 and 1 on this case. So this is the unit square. And we have the transformation that transforms this square into the parallelogram. Right. Remember last time on the first test when we're trying to find the matrix of the operation. Yeah, we haven't learned this yet, but we'll learn this tomorrow. Of course, this certainly will be on the next test as well. So we're going to have the transformation T here. That transformation T is going to be represented by the matrix. So we're going to try the matrix that turn S into P, or A times something from S to P. Right. Now remember, last time when we trying to find the matrix A, we just figure out what do we do with the matrix A. What is the transformation of the columns of the identity matrix. So first, let's just say we assume that it will transform this square into this parallelogram. So the first one, the point 0 and 1. This is the 1 and 0. That point 1 and 0, and this point is 0 and 1, which correspond to the columns of the matrix. Now the point 1 and 0, let's say that this point match to this one. 0 always match to 0, 0, so that one makes sense. So we have it will match 1 and 0 to this point here, which is 6 and 4. So the matrix A, the first one is going to be 6 and 4. Right. Next, 0 and 1. This point is going to go to this point, which is going to be 2 and 6. So the matrix A is represented by that matrix. So we have the matrix A. Let's just write that out. The matrix, the first one is the phi transformation and the transformation matrix. The transformation matrix is 6, 2, 4, and 6. Now we have that. Then we will have the formula. Since P is equal to the parallelogram is equal to the transformation of the unit square, we're going to say area of P is equal to, I have to be very careful with this. I could use the bar for the absolute for the determinant, but in this case we have the absolute values, so we have to do That to be careful, because the area must be positive. Determinant could be negative, so we put the bar just to make sure that everything is positive. And then the area of S. And you see, even though it takes a lot of calculation here, but the area of S, that area is equal to 1. Determinant of A, 6 times 6 minus 2 times 4, 36 minus 8. So that's going to be 28. So determinant is going to be 28. So 28 times 1 is going to be 28. So note that what we need to do is just find the transformation of 1 and 0. Stack that in the column. Transformation of 0 and 1. Put that in the column. That gives us the transformation matrix. And we have this little formula. The area of the unit square is simple. The area of, and then multiply by determinant. So this is just find determinant of a 2 by 2 matrix, which is very simple. So that is that. And then you will have yes, we do not need to worry about this point. Don't have to worry about the point 1 and 1. 1 and 1 we map into that. Remember, when we're trying to find the transformation matrix, the matrix to represent the transformation, we just need to find the transformation of the columns. And this one will be the transformation of, the linear combination of those two vectors. So that's just the combination of those two vectors. So just like we don't need to go to see what happened from the 0, 0 to 0, 0. We just need to match this. By the way, very important that the transformation has to be the linear transformation. So it can only map 0, 0 to 0, 0. If you have a let's say the parallelogram like this, then we have to transform that parallelogram to this corner before we do any calculation, because we do have to have 0, 0. So we can match 0, 0 with 0, 0. And then 1, 0 map to something, and 0, 1 map to that, and then we have it. Yeah, and usually I try to preserve the orientation, meaning that if we go counterclockwise, then we go counterclockwise from 0, 0 counterclockwise, 0, 0 counterclockwise, and we can have the parallelogram. Yeah. So that is where we use the transformation. So when we do that, the area of the unit square is simple. Determinant is very simple to calculate. Right. So you will have something like this on the test, even though it looks complicated, but what we have here is just very simple calculation. So for example, like 22 here, it says that the area of triangle given the point is this. The reason that I put this type of question on the test, because you will see this in some different books, and I just don't want you to be surprised. So you will see something like this. Pretty much in this case we have 3 points, so the area is pretty straightforward. We plus or minus x1, y1, 10, 4, and 1, x2, y2, and negative 7 and negative 4. Yeah, so we just do that. Again, we have the plus or minus here just to guarantee that the area must be positive. Just like in the last example, the last problem, we have to put the absolute values here to guarantee that the area is going to be positive. Right, so we just do that and find the area. Make sure it's positive. Same thing here. Put the points in. If it is equal to 0, then that is collinear, and if they're not, then they're not. So very straightforward. The formula will be given. You have a bunch of points. Put it in the determinant, and that's pretty much it. All right. So I think we cover on the topic, that is on the second test. Do you have any question? Any other question? By the way, we can also use this. Oh, actually, this one is in the, I think, explained in Calculus 3. It is a little more complicated. What we have is if we have a vector, in this case will be just x1, y1, and 1, and vector v what the formula we get from here is we're trying to find the area of a parallelogram that formed by two vectors u and v. So in Calculus 3, if we do the cross product, or is that in Calculus 2? Anyway, so when we're trying to find the magnitude of the cross product, will give us this area of the parallelogram. So the magnitude of the cross product, magnitude is 2 bars, and the whole parallelogram is u cross v. We have 1/2. It's going to give us the area of just half of the parallelogram. So we have half of it will be just a triangle. Right. So the reason we have 1, 1, 1 here, it's just like in the cross product we have ijk. Actually we 1, 1, 1 in that. So it acts in the same way. Yeah. But actually the proof of this is a lot more complicated than just what I just explained. But we can always do this. There are two vectors and the cross product. That's why we have the 1/2, and the 1 in here is acting like the cross product of the yijk. If we turn this like this, then we have ijk like kind of like 1, 1, 1. Right. And using that fact, if the cross product equal to 0, meaning that there is no area between the vector u and the vector v, so vector u and vector v point in the same direction, therefore they're collinear. Yeah, so both of this based on the cross product, and for some reason we did not cover cross product in this class, so that's why I just wrote the formula here, so at least you see it. Right. Do you have any other question? Right. Thank you very much for staying up and review with me, and I really appreciate that, because if I do it by myself I might leave some calculation mistake, and thanks for all the correction. Right. So I'm going to end the video here. It will take a few minutes before it is available online, but you should be able to see this later. I hope this helped you to prepare for the second test. Thank you for watching.